Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's topic, please do subscribe my channel. So my dear students, today I'm going to discuss all the postulates of Rutherford model which he made according to the alpha ray scattering experiment. That postulates of Rutherford model are also known as nuclear atomic model. So today I'm going to start with the Rutherford atomic model, also known as nuclear atomic model. So what was the first postulate according to the alpha ray scattering experiment? The first postulate is all the protons present in an atom are concentrated at heavy center called nucleus. So it was the discovery of nucleus in Rutherford model. Now, second point. The volume of nucleus is very small and is only a minute fraction of total volume of an atom. Nucleus has a diameter of the order of 10 to the minus 12 to 10 to the minus 13 centimeter, and whole atom has a diameter of order 10 to the minus 8 centimeter. So let me write this thing. The volume of nucleus is very small as compared to the whole volume of the atom. The diameter of nucleus is approximately 10 to the power minus 13 centimeter, and that of atom, diameter of whole atom is approximately 10 raised to the power minus 8 centimeter. So let us find the ratio. Let us find the ratio of diameter of the atom and the diameter of nucleus. So I am writing diameter of atom divided by diameter of nucleus. It comes out to be 10 to the power minus 8 divided by 10 to the power minus 13, and it comes out to be 10 to the power 5. That means the diameter of atom is 1 lakh times greater than the diameter of nucleus. So that was my second point. Now let's talk about the third point. There is empty space around the nucleus called extranuclear part. So I'm writing there is a empty space around the nucleus, called extranuclear part. Extranuclear part. In this part, electrons are present. In this part, electrons are present. The number of electrons in an atom is always equal to the number of protons present in the nucleus. So I am writing the number of electrons are always equal to the number of protons present in the nucleus. Now, as the nuclear part of atom is responsible for the mass of the atom, because you know that the mass of proton is 1837 times the mass of electron. I have already told you this thing in the previous lectures, that the mass of proton is 1837 times the mass of electron. So practically when we talk about the mass of an atom, we will talk about the mass of the protons, and all the protons are present in the nucleus, so it will be the mass of nucleus only. So I am writing as the nucleus part, as the nucleus part responsible for the mass of the atom is responsible for the mass of the atom the extranuclear part is responsible for its volume. Then the extranuclear part, the part which is present around the nucleus, the extranuclear part will be responsible for the volume of the atom. Now, the volume of the atom is about 10 to the power 15 times. Now, I am writing the volume of the atom is about the volume of the atom is about 10 raised to the power 15 times the volume of the nucleus. Volume of the nucleus. Now, let's talk about the fourth point. Electrons revolve around the nucleus. That's the super important point. Now, I'm writing electrons revolve around the nucleus. In closed orbits, in closed orbits with high speeds, with high speeds. Now, let's talk about when any substance is in the circular orbit, there will be two types of forces that will act upon him. That will be like the centrifugal force and the centripetal force. So, let us calculate the centrifugal and the centripetal force. First of all, let us understand. Assume this is the nucleus plus Zd. That's my orbit. Let me draw it again. So, what will happen? First of all, let's talk about centripetal force. What do we understand by centripetal force? Assume electron is here at this point. The nucleus is positively charged and the electron is negatively charged. So, nucleus will try to attract the negatively charged electron. Then what will happen? If the internal force is greater, if the nuclear charge or the nuclear attracting power is much stronger, then electron will follow a spiral path and finally collapse on the nucleus like this. So, the force acting on a body which brings that body to the center of the circular path is called centripetal force. So, let's talk about the centrifugal force now. Assume this is again the nucleus. Now I am making the circular orbit. So that is my circular orbit. Assume your electron is here. Now what is the centrifugal force? The centrifugal is the force which throws the body out of that circular path. Please have a look on the diagram. So this is the electron revolving in the path. If the centrifugal force will be the high, then this electron will get out of that path. This will be the result of centrifugal force. If centrifugal force is higher, that's my centrifugal force. So what is the condition if electron or any body have to revolve in a particular orbit? What will be the condition? The condition will be that the centripetal force and centrifugal force must be equal to each other. So I'm writing. Now if electron have to revolve in an orbit around nucleus, then centripetal force, then centripetal force must be equal to the centrifugal force. Now just let's talk about a condition. If centripetal force is higher than centrifugal force, then what will happen? The electron will follow this spiral path and will collapse on the nucleus. If centrifugal force is higher than centripetal force, then what will happen? The electron will be thrown out. Then the electron will be thrown out of the orbit away from the nucleus. So if the electron have to revolve in a orbit, then the centripetal force must be equal to the centrifugal force. Now, as the both forces are starting with C, to avoid confusion, I am taking my centripetal force to be force of attraction. I am writing small a, and centrifugal force to be F with a small c. So Fc will be my centrifugal force, and the Fa, the force of attraction, will be the centripetal force. So now let us discuss the Rutherford model in detail. I am making the diagram. That is my nucleus. Now this is my orbit. Assume your electron is present over here. That's my electron with a negative charge. Now there will be two forces acting on the electron. That is my Fa, or you can write centripetal force. As the electron is negative charge and the nucleus is positive charge, these are the opposite charges, so there will be the attraction. That's why I have taken a word Fa, where small stands for attraction. Now let's talk about the centrifugal force. The centrifugal force will act in the opposite direction. The centrifugal force will act on the opposite direction. Let it be like Fc, and let's call it centrifugal force. So now let's talk about the force of attraction first. In the previous lecture of Coulomb's law and the potential energy, I have make you understand the Coulomb's law. Coulomb's law states that the force of attraction is directly proportional to the product of the two charges Q1 and the Q2 divided by square of distance between them. What is the distance between them? Please have a look on the diagram. It is the radius of this orbit. It is the radius of this orbit will be the small r. Now let's come back to the formula. The centripetal force, that is Fa, will be equal to the K. What's my Q1? It's my nucleus. So Q1 is plus Ze. What's my Q2? Is my electron. It will be minus E divided by small r square. Now force of attraction comes out to be minus Kze square divided by small r square, where this negative sign This negative sign indicates the force of attractions. So now students, let's talk about the centrifugal force. I am writing the centrifugal force. The centrifugal force has a formula of m, that is the mass of electron, v, velocity of electron square, divided by small r. This is the formula for the centrifugal force that you must have learned in your junior classes. What is the m? M is mass of electron. What is v? It's velocity of electron. What is small r? It is the radius of orbit. Radius of orbit in which electron is rotating. In which electron is rotating. Now, what I have told you earlier, if electron has to revolve in a particular orbit, then the centripetal force must be equal to the centrifugal force. Now, let us put down the formulas over here. For the force of attraction, I am writing k z e square divided by small r square. I am ignoring the negative sign for the time being. What's the centrifugal force? It's m v square divided by small r. What will happen over here? The r will get cancelled by the square. It comes out to be k z e square divided by small r will be equal to the mv square. Now multiply both sides by 1 by 2. 1 by 2 and the 1 by 2. Now half mv square. What is half mv square? It is kinetic energy. Kinetic energy comes out to be k z e square divided by 2r. That comes out to be the kinetic energy. That's kz square divided by 2r. From this evaluation, what we are getting now? It is proving us that kinetic energy is directly proportional to the atomic number and inversely proportional to the radius of the orbit in which the electron is rotating. So, if atomic number is high, then the number of protons will be high. The more attracting power will be there of the nucleus, due to which the electron will possess the higher kinetic energy. So, I am writing more atomic number, then more protons, then more attractive forces, due to which electron will have higher kinetic energy. So now, if radius of orbit is higher, if radius of orbit is greater, then electron will be far away from nucleus and will have lesser kinetic energy and will have lesser kinetic energy. So let's talk about now potential energy. Now I'm talking about potential energy of an electron. So in the previous lecture we have studied about the potential energy. What's the formula for potential energy? It is K into Q1 into Q2 divided by small r. Now I'm writing K. What's my Q1? It's plus ZD because the nucleus. What's Q2? Is electron, it's minus E divided by small r. So my potential energy comes out to be minus K Z E square divided by small r, and here again this negative sign indicates attractions. So what's happening over here? Now potential energy directly proportional to the minus Z divided by small r. So potential energy, I am reciprocating Z by r, so it comes out to be r by z with a plus value. It is possible only in the cases of proportionalities, not in the actual calculations. Please keep this thing in mind. Now I am writing if radius of orbit is greater. If radius of orbit is greater, then electron will be far away from nucleus and will possess greater potential energy, and if atomic number Z is greater, then obviously the more proton, the more kinetic energy, and vice versa, lesser potential energy. So I am again drawing the diagram. That's my nucleus. It's a plus ZD. That's my orbit. Here's my electron. Now what will happen if electron is more closer towards the nucleus? Then there will be more kinetic energy. If electron is farther away from the nucleus, then there will be more potential energy. So this is the topic. Now let's talk about the total energy of the electron. Now we are talking about total energy of electron, that will be equal to obviously potential energy plus kinetic energy. What is my potential energy came out to be? It came out to be minus z e square k divided by small r. What's my kinetic energy came out to be? You can see it over here. I got the potential energy minus kz square by r and kinetic energy to be kz e square divided by 2r. Let's put it over here. It comes out to be z e square k divided by 2r. So this evaluation comes out to be minus z e square k divided by 2r. So this thing comes out to be total energy of the electron. So now you can easily see that again total energy is directly proportional to the radius of the orbit and inversely proportional to the atomic number. So now let's calculate the ratio of potential energy. The ratio of potential energy divided by kinetic energy. What is my potential energy? It's minus z e square k divided by small r. What's my kinetic energy? It's plus z square k divided by 2r. So it comes out to be z square got cancelled, smaller and the smaller cancelled. So potential energy comes out to be minus 2 times kinetic energy. So now let's talk about total energy again. I am writing again the total energy of electron. It comes out to be again potential energy plus kinetic energy. Now I am writing potential energy. Potential energy to be equal to minus 2 times kinetic energy plus kinetic energy. And it comes out to be minus kinetic energy. My total energy comes out to be minus kinetic energy. So that was the Rutherford model. I hope you got all the derivational points. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear doubts, then he or she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.